Welcome all for the video lectures in data structure. Today we are going to start with our fourth module, and our fourth module is all about queues and trees. First half of the fourth module will be about the queue concept, and our second half of the fourth module will be the tree concept. We'll start with the first session today, that is introduction to queue. Okay, what is queue? Queue is also a linear data structure similar to stack. How do we classify the data structure? We classify the data structures into two categories. One is linear data structure, the other one is non-linear data structure. In linear data structure, the data will be arranged sequentially. That is one data followed by the other data. We have a linear fashion of arrangement of data in case of linear structure. Whereas in a nonlinear data structure, it is randomly arranged. Under linear data structure, we have seen arrays belong to linear data structure, linked list belongs to linear data structure, stack belongs to linear data structure, and even queue belongs to linear data structure. So even in queue, the data are arranged in a sequential order, that is one data followed by the other data. And next is how we have seen that stack follows LIFO order. Here queue follows FIFO order. We have two ends in the queue, whereas in the stack we have only one end. Either it is an insertion or deletion. It is performed only at one end in the case of stack, that is top of stack. Whereas in queue we have two ends to perform the operation, that is front end and the rear end. Here is an example for the queue. This diagram represents the queue. We have two ends over here. One is rear end and the other is front end. Since we have two ends, it follows FIFO principle, whereas stack follows LIFO principle. Last in, last out, whether it is insertion or deletion, it can be done only at one end. Whereas in queue, we have two ends to perform the operation. One is front end, the other one is rear end. And here it follows the principle called FIFO, that is first in, first out. So the first inserted element will be deleted first. Whereas in stack, last inserted element was deleted first, since both the insertion and deletion was done at one end. Here in queue, we have two different ends. One end for insertion and the other end for deletion. That's why insertion, the first element will be the first to delete. Okay, the insertion operation we say it as NQ operation, and deletion operation we say it as DQ. And we do insertion in the rear end and we perform deletion at the front end. So in Q, we are using two ends. One is rear end and the other one is front end. To insert, we are using rear end, and to delete, we use front end. Okay, the operations what we use here, we call it as NQ operation and DQ operation. NQ is nothing but insertion of element into a queue, and DQ operation is nothing but deletion of an element into the queue. Okay, here both the front end and the rear end will be at the -1 position before starting the initialization of queue. That -1 position is nothing but we doesn't know where is the free space available in our system. It varies. So wherever there is a free space, your pointer will be pointing to that. So that since we cannot accurately point out where the free space is before starting an initialization of queue or before constructing a queue, your front end and your rear end will be at -1 position. When you start initializing or when you start performing any operation in a queue, both the front end and the rear end comes to the 0th position. Even in the queue, we have two ways of implementing queue. One is array based implementation, the other one is linked list implementation. Now what we are discussing is array based implementation. It will be starting with 0 to the maximum number of elements in the queue. Since we have not initialized the queue, our front end and the rear end will be at the -1 position initially. When we start performing an operation, or when we start constructing a queue, we bring that -1 position of front end and rear end to the 0th position. So whenever we want to insert an element, we will be incrementing our rear end by 1. Whenever we want to delete an element, we will be deleting the element at the front end and we will be incrementing our front end. This is the basic principle we follow in the queue. So we'll see the components of queue. We have front end and the rear end. Front end is for deletion operation, rear end is for the insertion operation, and we have element. Either it is an insertion or a deletion, we have an element, and maximum queue is the size of the array where we implement a queue in the array based implementation. These are all the components we have in a queue. Okay, and we represent queue logically. This is a diagram which is representing the queue. See, we have 5 elements inserted here. -2, 22, 77, 3 and 4 are the elements that we have in a queue. We insert an element through the rear end, and we delete an element through the front end. Initially, our front end and rear end will be at the -1 position, and when we start performing any operations in a queue, we bring that to the 0th position. So initially our front end and rear end will be at the 0th position. When I want to insert an element, I will be inserting at the rear end. That is, I will be inserting at the first 0 of queue. That is the first location. I will be inserting -2. Then I increment my pointer. That is, I increment my rear end to insert the second element 22. Then I increment the rear end to insert 77. Similarly, I increment my rear end to insert 3. Finally, I have inserted 4 by incrementing my rear end. Whereas, when I want to delete an element, where is my front end? My front end is at the first element. So, when I perform a DQ operation, for inserting an element, we say that as an NQ, and for deleting an element, we say that an DQ. So, when I perform NQ operation, I increment my rear end. When I perform DQ operation, where is my front end? My front end is at the first position. So, automatically -2 will be deleted. And I will be incrementing my front end. Then my front end goes to 22. So, second 22 will be deleted. That is why it is following FIFO order. That is first in, first out. This is what the basic features we have in a queue. So, what are all the basic features we have? Queue is a linear data structure. Here we have 2 ends to perform the operation. One is front end, the other one is rear end. Insertion we say it as NQ operation, and deletion we say it as DQ operation. So either an insertion or deletion we perform at 2 different ends. Whereas insertion is done, that is NQ operation is done in the rear end, and the DQ operation is done, that is deletion is done at the front end. These are all the basic features of queue. Shall we recall the features of what is queue? Queue is also a linear data structure. Even here the data are arranged sequentially. That is one data followed by the other data. Again we have 2 ends here. One is rear end and the other one is front end. And it follows FIFO principle, that is first in, first out. The element what has been inserted first will be deleted first. And we have 2 operations here, insertion and deletion. Insertion we call it as NQ, and deletion we call it as DQ operation. These 2 operations are performed with the 2 different ends. Insertion, NQ operation is done in the rear end with the rear end, and your DQ operation, that is deletion operation, is done at the DQ. That is with the front end. Okay, we will see what are all the real-time examples of a queue data structure. See, here is a scenario which is narrating the one-way road. See here, how does the traffic gets cleared, the car which has been entered first has to be let out first, followed by the second car, followed by the third car, followed by the fourth car. So what fashion does it follow? It follows first in, first out. That is, the first car entered has to be moved out first. So this is one very good real-time example for the queue data structure. See, this is also one more example narrating the queue data structure. When we want a service to be done, either it may be a ticket counter or any banking service, we stand in a queue to perform a specific task. Here, how does the services provided? The first in, first out. The person who has entered first will be serviced first. This is also one more a very good example of a queue data structure. So we'll see what are all the technical examples we have with the queue data structure. Consider a printer. So here we have a printer. A, B, C, D or the person who is using it, and the resource what we need is the printer. Now who has requested the printer first? C has requested it first, followed by A, followed by D, and followed by finally by the B. So how the printer will provide the service? Who has requested first? C has requested first. So C service will be provided. C will be printed first, followed by A, then followed by D, and the last requested, that is B, will be serviced last. And these are all the applications of a queue. In a computer, we will see few applications of queue. Disk scheduling. So whenever a disk has to be scheduled, it will be following the queue, that is FIFO principle, first in, first out. And even the data transfer. See, example, when you take your mobile, when you use a WhatsApp, how the data are delivered? The first data, the message which has been sent first will be delivered first. Okay, in terms of operating system, when you request a resource, the resource will be serviced using FCFS principle, that is first come first serve, which is applicable for queue, first in, first out. And a spooling in printers, what we have seen in the last example, it is also a very good example of an application of a queue. Then buffer for devices like keyboard. So when you give a buffering service, the service which has been requested first will be serviced first, which is following the principle of queue. Take a network. When you transfer a data, your routers or switches will be considering the first data which has been sent, and the service will be provided accordingly. This is all about the introduction of queue data structure. Thank you all.